Okay, welcome to this session. So in this session, we are going to discuss upon these two topics where we're going to have a process identifying concave polygons or splitting and concave polygon. Right? So now so far from the session 1, we are discussed about the point OpenGL function and its attributes, line OpenGL function and its attributes, as well as the OpenGL point attribute and the OpenGL line attribute. And in session 2, we have discussed the polygon basics and even the types of polygon. It can be simple polygon or complex polygon. And if I talk about a simple polygon, it can be convex or the concave polygon, and even the different types of fill area and what do you mean by a fill region. So with respect to this, we have discussed about the fill attributes. So now in this session, we will discuss about identifying a concave polygon and splitting the concave polygon. So because see, these two topics are necessary because while discussing in the session 2, I told that handling convex polygons in OpenGL, you have direct APIs and which you can do it easily. But once you are going to talk with about concave polygons, it's not easier. Hence, the OpenGL, whenever it wants to fill a concave polygon, it is going to split the polygon. It's going to split the polygon into n number of or set of convex polygons. And for this convex polygons, we'll use the OpenGL functions and we're going to fill the interior of those convex polygons. Hence, in this session, we are going to discuss how do we identify a concave polygon, and once it has been identified to be a concave polygon, how we are going to split the concave polygon. So now we'll discuss about how exactly we are going to identify a concave polygon. So now whenever we're going to talk about identifying a concave polygon, so we are going to have some basis for constructing a concave polygon, so which we use it for identification of algorithm. And so now whatever the basis we are going to discuss now, so this is going to be a basic for constructing an algorithm for identification of a concave. The first basic construct can be the properties, that is the properties which we already have discussed in the previous session when I was discussing about the types of polygon. And if you want to differentiate the convex polygon with the concave polygon, we had used three properties, that is the interior angle and the extended edge and two random points anywhere inside the interior of the polygon. Hence, I can use this property as a basis for constructing a concave polygon for identification. And the second method, we can use something called as relative position. So in this relative position, if you observe, I am going to draw a reference line on any given edge. For example, in this case, I have drawn a reference line for the edge between V1 V5, and if you observe, when I have drawn the line on this edge as a reference, all the 5 points, all the 5 vertices is going to be on the reference line or at one side of the reference line, like V1 V5 or on the reference line, remaining all the 3 vertices are at the other side. Hence, now this is where we call the relative position. Now if I do the same thing for all the edges, I still end up with the same, that is, I'll be having 2 vertices on the reference line and remaining 3 vertices, all the 3 will be on one side. But whereas, just look at this example, if it is a concave polygon and if I am trying to draw a reference line on this edge, you can just observe here. So V4 and V5 are on the reference line and V2, V3 are at one side and V1 is going to be at the other side. Now this is going to give me enough information that it is going to be a concave polygon. Hence this is going to be a relative position basis for constructing a concave identification algorithm. And the next method is the cross product. That is, we are going to work on the edges. Now I am going to have E1 edge, E2, E3, E4, E5. I am going to have 5 edges here. Now I am going to find the cross product of this. So using the cross product of E1 and E2, I am going to find the result of this cross product. Similarly, find the cross product of E2, E3, E3, E4, E4, E5 and E5, E1. In this case, if you observe, now this is the edge 1 which is going to make this polygon to look like an concave polygon. Hence, for this reason, if I calculate, so usually the cross product of this is going to be negative value or less than 0. Remaining all the edges cross product will be positive value or greater than 0. And so this is going to, if I have at least one cross product of the edge which is going to be negative or less than 0, or in the other case all the values will be negative and any one cross product or at least one cross product is going to be positive. Even in that case, we are going to call this as a concave polygon. So now you may be thinking, what is this cross product here all is going to be, and how exactly we are going to find the edge and find the cross product of the edge. Now we will just discuss how exactly this cross product method is going to work. Then we will see how the relative position method is going to work. Any of these properties or the basic properties, so which is going to point any one of this condition. So while having identification algorithm for concave, so this too, any of this one method will be good enough to develop an algorithm. Hence, we will just see how the cross product method is going to work for the identification of algorithm, and how relative position is going to work for identification of concave polygons. So now I can use this properties relative position cross product whenever I want to identify. You can use any of this method. Once the identification is done, the splitting should occur. The phase 2 is going to start. In the phase 1, use any one of this. In the phase 2, we will going to discuss how we are going to split a polygon, how we are going to split a concave polygons. So either using a cross product method or using relative position method. So now first we will see how the cross product is going to be used for splitting the concave polygons. Now in the phase 1, using any one of those 3 methods, we have identified it is going to be a concave polygon. Now we are going to split a concave polygon based upon any one of this method. And so now first we will discuss the cross product method, then we will see how the relative position method is going to work. And so now whenever we are going to have the cross product method, we are going to work on the edges, that is E1, E2, E3, E4, E5. We have just labeled this starting from E1 to E5, and we are aware that we are going to have this 5 vertices starting from V1, V2, V3, V4, V5. These are the 5 vertices. So now whenever I want to work with the cross product of the edges, I should know what is the x value and the y value of every vertices. And so now in this given example diagram, so let me put a coordinate system, and we are going to say what is the value of V1 x value and the y value. Fine. So roughly I am going to put the value of x and y. It's not going to be the actual values. So don't get confused with the values what I'm going to use for V1 with the x and y. So it may not be the actual values with the given coordinate system. So right now at approximate, we will just put what is the V1 is going to be. So I'm saying V1 as x is 1 and y is 1. Hence the V1 is going to be a point or vertices at 1 comma 1. Similarly, so v2 is going to be x at 5 and y is going to be at 2. Similarly, v3 is going to be at 4 on x-axis and 4 on y-axis. And v4 is going to be 2 on the x-axis and 5 on the y-axis. And the v5 is going to be 3 on the x-axis and 3 on the y-axis. And these are the 5 points what we are going to have whenever we are going to define an vertices. Fine. So now once we have this vertices and the points, so now my next job is I need to find the edges. I need to find the edge vector. Hence, I need to find what is EI. When I say edge 1, I is going to be 1. That is EI equals vertices I plus 1 minus vertices of I. That is, if I want to find the edge 1, I'll be using vertices 2 minus vertices 1. Hence, the edge 1 is going to be vertices 2 minus vertices 1. Hence, that is what we are going to have. So, E1 equals V2 minus V1. E2 is V3 minus V2. E3 equals V4 minus V3. E4 is V5 minus V4. And when I say E5, now don't say it as V5 or V6 minus V1. So now when I'm going to have E5, so we are just going to have, so now it is going to be back again to V1. Hence it is V1 minus V5. It is not V6 minus V5. We need to cycle it back. And these are the edges what we need to compute. Now we know what is V1 to V5. I'm just going to substitute for V1, V2 and we are going to find what is E1. So now V2 is 5, 2 and the V1 is 1, 1. I'm going to subtract this. So 5 minus 1 is 4, that is x1 minus x2 is 4, y1 minus y2 is 1. Hence 5 minus 1 is 4, 2 minus 1 is 1. So I'm going to have E1. So similarly for E2, where we need to have V3 minus V2. So V3 is 4, 4 and V2 is 5, 2. And I'm going to subtract this. Now 4 minus 5 is minus 1. 4 minus 2 is 2. So similarly for E3, we are going to end with minus 2, 1. And for E4, 1, minus 2. And for E5, that is, I'm going to have V1, which is 1, 1. And V5, it is 3, 3. So with the subtraction, I'm going to end with minus 2, minus 2. Hence, in the cross product, with knowing the points of every vertices, the x and y value, we are going to find the edges. We are going to find the edge vector. So edge 1 vector is 4, 1, minus 1, 2, minus 2, 1, 1, minus 2, minus 2, minus 2. So once you know what are the edges, so now it's the time to find the cross product. So to find the cross product, so this is the formula what we are going to use. So for every cross product, I'm going to call this as Z component. We need to find the Z component. So based upon the Z component, either it is negative or positive, we will decide whether it is a concave. If it is a concave, so the splitting should happen at what point of the concave polygon. Hence, now we are going to find the Z component as Zi equals Ei cross product with Ej. So when I am going to find the Z1, this is going to be E1 into E2. So I am just going to be in an anti-clockwise direction. So E1 into E2, the Z1 component. E2 into E3, I am going to have Z2 component. E3 to E4, Z3 component. Hence, I will just go in an anti-clockwise direction. So hence, so once I want to have cross product, I will take the x value of EI and multiply it with the y value of EJ. Subtract with the x value of EJ multiplied with the y value of EI. That is what we are going to find the cross product. This is the cross product, and the result of the cross product we are going to call this as Z component. And so now if I want to have E1, so E1 equals, sorry, Z1 equals E1 into E2, so which is 4 comma 1. So E1 is 4 comma 1 cross product with E2, which is minus 1 comma 2. Hence the x value of E1 multiplied with the y value of E2. Hence, so 4 into 2, we are going to have 4 into 2 over here. Subtract with x value of E2 multiplied with the y value of E1. Hence, we are going to have minus 1 into 1. And I'm going to have 4 into 2 is 8. Subtracted with minus 1 into 1, that is minus 1. Hence, if I solve this, I'm going to end with 9. Fine. And this is how we are going to find Z1. So similarly, Z2. Z2 is between E2 and E3, the cross product of E2 and E3. So E2 is minus 1 comma 2 and E3 is minus 2 comma 1. And x value into y value, that is minus 1 into 2. X value into y value, you're going to have minus 2 into 2. So which is equivalent to minus 1 subtracted with minus 4, which I'm going to end with 3. So similarly, observe for Z3, I'm going to end with 3. And for Z4, I'm going to end with minus 6. And for the Z5, we're going to end with 6. Again, just observe, I'm going in a cyclic order. So for E5, I'm cross producing with E1, E5 and E1. So now we know what is the 5 Z components for the 5 edges. Hence we are going to have Z1 as 9, Z2 as 3, Z3 as 3, Z4 as minus 6 and Z5 as 6. And these are the cross products of the edges. I'm going to have 5 cross products and so I'm going to have 5 Z components. So now just observe, so this Z1 is a positive value, that is 9, it is greater than 0. Again, even the Z2 is also positive value. Z3 is a positive value. And now Z4 is the negative value. This is what I was talking about. And Z5 is a positive value. Hence now all are positive values except the Z4 component. And this is giving me enough proof to say the given polygon is a concave polygon. And now this is the component which is giving me it as concave polygon. Hence the cross product of this edge. The cross product of this edge E4 and E5 is the one which is giving me a concave polygon. And this is the point where we need to split the polygon to look like a set of convex polygon. So now in this component, in this cross product, we are going to pick the EI edge. Always pick the EI edge for splitting of an concave polygon. So in this cross product, when I say cross product is EI into EJ, now EI is E4, EJ is E5. Always pick the EI edge to split a concave polygon into set of convex polygon. Hence, we are going to pick the edge E4 for a splitting operation. This is the point where the splitting of the concave polygon should happen. Hence, so now we have identified whether the given polygon is a concave polygon or not, and we have identified where the split should happen. This is what the cross product is going to do. Hence, so now at the edge E4, we are going to extend the edge E4, and wherever the edge E4 is going to cross another edge, that is the point where we are going to split. Now I am going to extend the edge E4 until it's going to cross another edge, and we are going to split the polygon exactly at that point. Hence, now we have been extended. Now the edge E4. Now this becomes one convex polygon, and this becomes the second convex polygon. Now I have got two convex polygons. As there was one concave polygon, I have identified it as concave polygon, and even I have identified where the splitting should happen, and using the split I have made this to look like two convex polygon. Now the filling of the convex polygon will be easily handled by your OpenGL fill functions. Fine. Now this is going to be about a cross product, and now this method can be called as cross product method, or this can be called as vector method. So the whatever the name you give is going to suit this. As when I say vector method, every edge is defined as vector, and we are going to subject it to a cross product. And so now we will see how exact the relative position method is going to help me in identifying it as a concave polygon, and how and where the split should happen. Hence we will see what is the relative position is going to be. So in the relative position method, we are going to have the same polygon. The first step is by taking its turn. Now I will just take the vertices V1, and I will shift the entire polygon to an origin of a coordinate system. I will make sure, so V1, whatever the x and y value right now it's going to be, I will make sure I am going to shift this point at the origin of the coordinate system. Once it is at the origin, I will rotate the polygon in such a way that the next preceding vertices should be on the same x-axis in line. That is, the V1 and V2 should be on the same line on the given x-axis as the reference axis. On doing this, at the time when V1 and V2 has been rotated, the polygon has been rotated so that V2 will be on the same axis, and we observe the remaining three vertices. Because V1 and V2 will be on the same reference line, observe the three other vertices. Are they at the one side of this division or the reference line? If they are at the one side, then it is going to be a convex, but not it. We are not going to decide it is going to be a convex polygon, concave only at V1. Now we will shift the operation to V2. We'll make the V2 to be at the origin and rotate the polygon in such a way that V2 and V3 will be on the same reference line, and observe the remaining 3 points where they are staying. Again, make V3 to be at the origin and make the V4 to be at the point. Hence, so instead of checking for the remaining 3 points, just check at the next successive vertex. If I am choosing V1 to be at the origin, make V2 to also be on the reference line, then check where V3 is. Is it with the remaining points or not? Hence, so now we'll just see how exactly this is going to work. Now, I'm just going to take the coordinate system, and this is the origin. So now my polygon should be shifted in such a way that V1 is going to be at the origin. Something like this. I'm shifting the polygon, and this is going to be the reference line for me. Now, keeping this as reference line, I need to rotate the polygon in such a way that V1 should still be at the origin and V2 should be on this reference line. So something like this I'm going to rotate. So right now observe. So V1 and V2 both are in the same reference line, and if we say V3 is going to be in the same side where V4 and V5 is going to be, or above the reference line. And now the next part, now this is done, and so right now still we are not sure enough whether it's going to be a convex polygon or concave polygon. I should do the same process for every vertices. Only then I can come to a conclusion. So now we will shift V2 to the origin and rotate so that V3 is going to be at the reference line. So something I have rotated, so where V2 is going to be at the origin and V3 is at the line. So now remaining all the 3 vertices or the V4 vertices is going to be at one side. So now still we are not completed. Now we should do the same for V3. Now V3 should be at the origin and V4 should be at the reference line. So still all the points are on the same side. So now we should continue. We'll make V4 to be at the origin and V5 on the reference line. So we have V4 the origin and V5 reference line. Oh, now just observe now. Now just observe. So the next point, which is to be V1, V1 is going to be below the reference line and V2 and V3 are above the reference line. So this means right now all the 3 points other than V4, V5, the remaining 3 points are not on the same side of a reference line. And now this will give me enough evidence to say it is going to be a concave polygon. And so now if the splitting should happen, now it's going to happen with the reference line. And so right now edge V4 and V5 should be used for splitting operation. Using the reference line, wherever the reference line crosses the edges, that is where the splitting should happen. Now we'll just move further. We'll make V5 to be at the origin and we are going to have V1 on the reference line. So now just observe here, that next point. Now just don't look at this 3 points, just look at the next point, V2. So V2 is going to be at the one side. Hence again this V5 involved is going to cross the edge. But right now the next point is going to be above the reference line. Hence we are not going to consider this edge for the splitting operation. Hence the only edge what we have got is V4 comma V5. Hence the V4 V5 will be extended and wherever the line is going to meet, I am going to split it into 2 convex polygons. Hence now this method we call this as rotational method, because that is what we are shifting to origin and we are trying to rotate. Hence we are going to call this as rotational method, or we are going to call this as relative position method, whatever is going to suit. Both are one and the same. Hence now these are the 2 methods which we are going to use, the vector method or the cross product method, to identify and split a concave polygon. Or I can use relative position as rotational method or relative position method again to identify and split a polygon using the reference axis or a reference line. Now this is what this session was supposed to be. Hence, thank you.